Okay, so the first problem was that we were given an eighth term being 64 and a 10th term being 100. And the question asked, which of the following can not be our A9? Okay, and our choices were 82, negative 82, or 80 and negative 80. Okay, so that's the question. First, what we will start with is looking at the arithmetic sequence. Okay, so to find the A9 of the arithmetic sequence, first we have to find the common difference. And the common difference, the D, can be found by subtracting 100 minus 64 over 10 minus 8. That's 36 over 2, which is 18. That's our common difference. And then what we can do is we can take our eighth term, which is 64. If we add 18 to it, we would get the ninth term, which is 82. So we know that our A9 is 82 for the arithmetic sequence. So we can cross that answer off because that is a possible answer. Next, we're going to work on the geometric sequence. The geometric sequence. The explicit formula is this. Okay, and what we're going to do is very similar to what we did in the last unit when we took our equation, our general equation of an exponential form, and we divided it top and bottom. So we chose the bigger x and put it on the top and the smaller x on the bottom. So we're going to do the same thing with our points. We're going to choose the bigger n and we will put those on the top. So in this equation, we will have 100 equals a1 r to the 10 minus 1 over 64 equals a1 r to the 8 minus 1. That will give us 100 over 64 equals, you'll see that the a1's knock out, and it's r to the 9 over r to the 7. And remember that division is subtraction. So it's 100 divided by 64 is equal to r squared. In order to get r, we'd have to take the square root of both sides. And remember, anytime we take the square root, it must be plus or minus. So it's plus or minus 10 over 8 is our common ratio. However, we could reduce that and make it plus or minus 5 over 4n. I'm sorry, r. Okay, 5 over 4. So if we plug either of them into the explicit formula, we would have this, or we'd have that. We'd have two possibilities. Okay. So with the geometric sequence, it is possible for numbers to go positive, negative, because if you have a negative number as your ratio, for example, if we had negative 1, if we had it to an even power, that would be like negative 1 times negative 1. That generates a positive number. If we had negative 1 to an odd, that's like negative 1 times negative 1 times negative 1. That would be negative 1. Okay. So that explains why with this one, this number, this negative, is going to generate a sequence that might look like, 64, comma, negative 80, comma, 100, whereby this one would generate 64, comma, 80, comma, 100. And I'll show you in a minute how we're going to get those, the 80 and the negative 80. So we're going to take this formula. I'm only going to do the 5/4 up here. So we have AN is equal to A1, our 5/4, n minus 1. And we're going to take one of the points, and we're going to plug it in to calculate our A1. I'll choose the smaller one, which is 64. Okay. This is 64 equals A1, 5/4 to the 7th. To solve for A1, we would multiply both sides by the reciprocal, which is 4/5 to the 7th power. Now, this is not a very pleasant number. It would come out really strange on your calculator. So we're going to just leave this whole thing as your A1. So when we plug it back into the explicit formula, in place of A1, I'm just going to put this 64 4/5 to the 7. And then we'll put this 5/4 n minus 1. Okay. And if we want to find a 9th term, we would just put in the 9 in place of n. Okay. And if you do the math, you would get 80. So we know that 80 could be one of the possible answers. And because this was a negative, we know that it could also be negative 80. So up here, we can cross out 80 and negative 80, and we know that the answer cannot be negative 82.